Hello, I'm Mirdad Simkhani, your college algebra professor, and this lesson is about binomial theorem. First, in this video, we study Pascal triangle, which has a pattern to develop. This has 5 rows. We can continue this with more rows, and you can see each new row has one more number, and you have probably guessed what the next row would be. 1, 5, 10, 10, 5, 1, and this continues forever. Pascal was a French philosopher, mathematician, and physicist. He even invented one of the earliest mechanical calculators. But before Pascal, hundreds of years earlier, Chinese used this table, had this table developed for solving algebraic equations. And here we're going to use this and relate it to expansion of binomials. A binomial is a power. A binomial power is a power of 2 monomials. A binomial, by definition, is a pair of monomials added together. Now, the monomials could just be plain x and y, or anything else, or 5x minus 3y, for example. They can be, those are binomials too. And these are powers of binomials: second power, third power. I guess we can do first power and zeroth power as well. From your earlier college algebra classes, you expanded this, and you already know an algebraic identity that tells you x plus y quantity squared is x squared plus 2xy plus y squared. And notice that the coefficients, which are 1, 2, and 1, those coefficients are the same numbers in this row of the Pascal triangle. 1x squared, 2xy, and 1y squared. And this, we know this from the FOIL method that you did for multiplying 2 binomials. In this case, this is x plus y times x plus y. Let me write it this way, make the second one. Write them as, put the coefficients in there. 1x plus 1y. And then when we multiply, so you have x times 1x, that will give you 1x squared. It's not necessary to write 1, but I want to demonstrate the relationship to the Pascal triangle and how you get that second row. So x times 1x squared, x times 1y. There's no need for that. Okay. So now I have, so far I have x times 1x. I have to multiply x times 1y, and that will give me 1 xy, and then add y times 1x and y times 1y. Y times 1x would be 1xy again, or yx, the same thing, plus y times 1y would be 1y squared. Now when you add these, there's only one x squared, so that's 1x squared, plus here you have 1 plus 1, which is 1 plus 2 times xy, and then plus 1y squared. Now, if you go back to the table, you can see the way the table is made. You start with 1, and then 1, 1, and then to build the next row, always the sides, there are always 1s. You bring them 1 down, and then the middle ones, you add the top 2, like 1 plus 1 is 2. And then when you go to the next row, 1 plus 2 is 3, 2 plus 1 is 3. And the next row, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and so on. And that's how we got 1, 5, 10, 10, 5, 1. 1 plus 4 is 5, 4 plus 6, 10, 6 plus 4, 10, 5, 4 plus 1, 5, and so on. So that's how that is made. So 1 plus 1 will give you that middle term. Now similarly for x plus y cubed, first of all, you know this again, this cubic power and the quadratic power, those two were two famous algebraic identities that you should have seen in your previous, and also in this class too. When you raise this binomial to the third power, what you get is x cubed plus 3x squared times y plus 3x y squared plus y cubed. And notice that the coefficients 1, 3, 3, 1 are exactly these coefficients. And again, similar to what we did for the second power, here too you can write this as x. You can write this as x plus y times x plus y quantity squared, which is the previous result, which is x squared plus 2xy plus y squared. Isn't that the power 3 is x plus y times x plus y to the second power, which is x squared plus 2xy plus y squared. Now, again, multiply x times x squared, you get x cubed, plus x times 2xy, that gives you 2x squared y. X times y squared is xy squared. And now multiply the y. Y times x squared is 1, right? 1 x squared y. Y times 2xy is 2xy squared, and y times y squared is y cubed. Now when you add, you get what? X cubed plus, this is 2 plus 1, or 1, I'm going to write it as 1 plus 2, x squared y, plus this one I write as 2 plus 1, xy squared plus y cubed. And notice that the 1 plus 2 and the 2 plus 1, those are how you get the 3's in the middle. And so you're adding the above row. You see these pairs of the above entries. 1 plus 2 is 3, and then 2 plus 1 is 3. So that's what these two are, 1 plus 2 and 2 plus 1. Now, for expansion of this x plus y quantity to the fourth, similarly you can you can see how that relates to the table. But this one, once you have the table, you don't need to spend time doing all this algebra. You can just use the coefficient in the table. So for the fourth power, you have 1, 4, 6, 4, 1. And that gives you x to the fourth, 1 times x to the fourth. And then the next one would be 4. The coefficient is 4. But notice that as you move from left to right, you reduce the power of x while you're increasing the power of y. So the power of x is lowered to 3, and now y appears 1. You can think of this first term as x to the fourth, y to the 0. Y to the 0 is 1, right? So that's x to the fourth times 1. So the next coefficient is 6, right? From the table, 6, and then 4, and then 1, and the coefficients are symmetrical, right? So that would be 6. Lower the power of x, so that's x squared. Higher the power of y, get y squared. Plus, after 6, you see this 6 is the middle one. For even powers, the middle term is split the power 2 plus 2. And always the sum of the powers should equal to the power of the binomial, 4 in this case. This is 3 plus 1. This is y to the 1. 3 plus 1 is 4. 2 plus 2 is 4, and so on. The next coefficient is 4, is symmetrical. And then lower x, higher y, and finally y to the fourth. Okay. And now here's an example. We're going to do 2x minus y to the fifth power, and we want to expand it. So first of all, there are coefficients to fill in, and also the powers. The two terms here are now 2x plus minus y. So the second term is minus y. So the powers, starting with the first power, would be 5. And then this would have power 0. As you reduce the first power, you increase the second power. So here you have 4. And then after that you have 3. And then 2 for the 2x. And then 1, and then 0. Now, for the minus y, you start with 0, the second term to the 0, and then to the first power, and then to the second power. I'm writing these powers, and I'm simplifying it later, so you don't need to write the first power, but I'm writing it so you see the pattern. And then the 2 here, for the minus y, you increase it to 3. Again, if you add the powers, you should get 5 for the fifth power binomial. You should get 5 as a sum of the powers. So here, the minus y would go up to 4, and then finally up to 5. And now the coefficients to fill in. So these are the binomial coefficients. So I can fill them in. So these are the binomial coefficients that you fill in. For the fifth power, first of all, for all of them, the first one is 1, the last one is 1. It's symmetrical. And then for the fifth power, the first one is 5, and the second coefficient is 5, and the one before the last is also 5. And then, as you notice, the middle ones, because you add 4 plus 6, you get 10. 6 plus 4, you get 10. So the middle two should be 10. And again, the symmetry helps you to check to make sure the coefficients are correct. And now, finally, you just simplify. So you don't need to write the 1 here. This is 2x to the power 5. You have to raise 2 to the power 5, which is 32. So that would be 32x to the 5th power. Negative y to the 0 is 1. And the next one, let me figure out the sign. Negative y to the 1st power is negative y. So I put the negative in front, so that the next term should be minus. By the way, when one coefficient is positive, the other one is negative, the signs alternate. So the first coefficient here is positive, the next one negative, and then positive, negative, and so on. To figure out the coefficient, you have 2x to the power 4. So you have 2 to the 4, which is 16, times 5. So you have to figure what that is. So first of all, I have a 5, and then 2 to the 4 is 16. I will simplify later. And then x to the 4th power, y to the 1st power. You don't need to write the 1st power, just write y. And then the next one, negative y squared, that will be positive. Now you have a 10 plus 10 times 2 to the 3rd power times x cubed. So that will be 8 times x cubed y squared. And then the next one, actually minus, the next one is negative. You have negative y to the 3rd power, so that will be negative. And then there is a 10 here in front. And 2 to the 2 is 4 times 4. X is squared and y is cubed. And then the next one, negative 4 to the 4th power, an even power, that's a plus. 5 times 2x, right? 2x to the power 1 is just 2x. So you have 2 times 5 is 10. 10x y to the 4th power. And then the numbers in the middle, you can simplify. This one is 80, right? And this one is also 80. This one is minus 40, and so on. So that's how you expand binomials by using Pascal triangle. Pascal triangle is one way to expand binomials. But the problem with Pascal triangle is that in order to, for example, if I want to raise to the 8th power, then I need to generate this triangle to the 8th power. After 5 you get 6, 7, and then 8, 3 more rows to fill in, and that may take a while to do. In the next video we learn the binomial coefficient. We find the formula to generate these coefficients. So we do it by formula, which is called the binomial formula. So watch the next video.